Okay, this is the LeetCode Biweekly contest. I typically solve 3 or 4 of the 4 questions in these and program in Ruby. So, fingers crossed. I'll be trying to explain my thinking throughout the process and while I'm solving all of these as much as I can without slowing down too much. So, hopefully, this is interesting and helpful. Wish me luck. Let's go. Okay, I'm opening all of them at once just in case there's an issue with loading, because that's happened in previous contests. Check if array is good. Okay. Base n. N plus 1, exactly once, plus 2 occurrences of n. Okay. So, okay. My tab is frozen. That's helpful. Come on. Basically, what I'm going to do is I can generate the array. Why is this in TypeScript? I want Ruby. I can generate the array, sort that array, and see if it's equal. So, basically, what I'm going to do is 1 to n inclusive dot 2a plus n is an array equals nums dot sort. This is fine in terms of the time complexity. So, it should be false, true, false, false. Okay. Equal n. Right. That's a good point. N equals num.length minus 1. Okay. Right. This is 0 to... Do I want that to be nums.length or nums.length minus 1? Honestly, it's easier to just run it. Okay, so true, true, or false, true, true. Yeah, that one should actually be true. That's right. This seems to work, so I should be good to go. Participated, judging. Doesn't count as participate till I submit. Okay, sort vowels in a string. Easy peasy. Consonants remain in their original place, more formally if there's an index. Okay, vowels must be sorted in the non-decreasing order of their ASCII values, their vowels. But they could be capital or lowercase. That's annoying. Okay. According to the ASCII value. Is that what I would get just from a normal sort? Here, lowercase or uppercase. Okay. So uppercase comes before lowercase. Probably that's the default for sorting, but I'll certainly be able to test it in this test example. Okay. No, stop defaulting to TypeScript. I program in Ruby. Oh boy. Okay. So vowels equals blank, consonants. Basically, I want to pull out what all the vowels and consonants are. Ooh, I'm dumb. And then what I'm going to do each time is just create a new string, iterate through the current string. If it's a consonant, I put the consonant without sorting. If it's a vowel, I put the vowel, but I'm going to sort the vowels. Okay, so s.each char, do char, if char dot downcase. So if in here I want to do just an array of vowels. Okay, so if that array includes that, i.e. if it's a vowel, and this doesn't count y based on the example, then I would push it into vowels. Else I would push it into consonants. I feel I can't think as fast when I'm explaining. That's fine. Okay, so str is going to be blank. I'm going to do vowels.sort. I'm going to do s.each char. Do char. So now, use the exact line again. If it's a vowel, then I'm going to do str plus equals vowels.shift. Note that in Ruby, shift is O of 1, so this doesn't lead to time complexity issues. If I were not doing Ruby, I could reverse the array and then pop, or I could even just iterate if I didn't want to destroy my array, because why not? And then I should just return str. Ruby has implicit returns. Okay. Ah, consonants. I spelled it inconsistently. I spelled it with a T. That's no good. Okay. Easy fix. So I get, oh, no, the uppercase come first. Okay. So 2 options. I could either do a custom sorting, or I could sort by, what is ASCII value? Ord char? Is that going to get the ASCII value? Ord. Is that a Python method? Okay. I'm going to try this without looking, so I'm just going to sort by manually. What are my constraints here? 10 to the 5, that's fine. Okay. So char. So I can just do u eiou dot index char. Okay. This isn't strictly ideal in the sense I'm iterating through that entire string each time. However, wait. I'm wondering if I actually needed to do this, or if I'm an idiot who can't read. I'm an idiot who can't read. It was sorted correctly the first time, and I'm just an idiot who can't read. Okay. What else is new? What? Time limit exceeded? How? Okay, well, I can reduce the search part. These equals set A, E, I, O, U, A, E, I, O, U. This probably isn't the contributing factor. These, oh man, this is gonna be bad for my time if I try this too. Okay, and then I can just do char. So that's a little faster, but fundamentally, what's the problem here? It's only 10 to the 5th. So 10 to the 5th, I should just be able to sort. I could get rid of consonants entirely, actually. Because if it's not a vowel, then it's a consonant, and then I can just do str plus equals char. But again, like that affects my space complexity, but none of that should affect my time complexity. I really don't want to get stuck on this problem, so I'm going to submit again, even though that's probably not the best time-wise. It's going to be too slow because I didn't change time complexity. Shoot. Okay. Why can't I sort if it's 10 to the 5? Fine. I'm going to do this a totally different way. Okay. So, totally new strategy. I'm going to tally. Count equals s.split dot tally. Okay. Now vowels equals blank. Now I'm going to go through each of the vowels in order. I don't know why that didn't work, though. That's going to bug me. Okay, so this is strictly O of n. Dot each, do vowel, and then vowels. Okay, wait, so I have a vowel. So I'm going to do count of vowel dot times. So for each time, I'm going to add that vowel to vowels. Okay. Now this should be O of n. I want to test, does this work in general? Or did I somehow ruin it? I ruined it. I love that. Right. I can't do count because then it doesn't default to 0. So count equals hash dot new defaulting to 0. So then s dot split. I don't even need to split it then because that's an array method, but this isn't. Each char. So I have char, and then I say count of char plus equals 1. I could have eaten another 5-minute penalty if I didn't run this on the test code first. I got rid of VS, didn't I? That was dumb. Okay. Here, VS equals. By the way, my mouse is sort of stopped working. It has difficulties when I try to like highlight text, which is why I'm doing this copy paste instead of highlighting. Kind of dumb. What? And I didn't define str. See, this is the problem with rewriting most but not all of your code. Okay, so that works. It's giving me the correct answers. I'm going to submit. It's now O of n instead of O of n log n. So again, n log n. Why? What am I fundamentally thinking wrong about this? Oh, right, that should be a set. It still got each works on a set, right? Yeah, that's fine. Fine. I'll get rid of str. Oh my god, my time's gonna be so bad. Each char dot with index I, then str. No. Then si equals vowels dot shift. And I created. Right. Now it's going to mysteriously fail. Maybe I don't know what the difference is. Why would that not pass? God, okay. Man, I have like 15-minute penalty. That's more time than I've spent. Okay, 0 indexed array, positive integer x. Initially at position 0, you can visit other positions. If you're in I, you can move to any later position. For each position I you visit, you get a score of I. And the parities differ. Maximum total score. So this is going to be dynamic programming. Okay. What are parities? Is parities just a different mod 2? Okay. So 2, 6, 1, 9. Got you. Okay. You lose a score of X. Okay. So basically, I want to get the maximum score. If I'm going to something that's the same mod 2, then oh my god, then I just add on that number. However, if I go to something that is a different value mod 2, then I subtract x. So here I could have gone 2, 6, 2, and wouldn't have subtracted x, but 9 plus 1 minus 5 is still bigger than 2. So it would make more sense to add the 1 and 9 and take the penalty of 5 than add the 2. Okay. Here, all of it's even. That's handy. Man, I must have done something in TypeScript right before this contest I forgot about, or most recently. One of the JavaScript problems. Okay. So there's definitely dynamic programming. I would store my current position and my current parity. That's really easy, actually. And it's only 10 to the 5. They're all positive. That's handy. Okay, so I like doing this with a helper function. So nums is nums, x is x. And then I'm going to do score, starting at position 0, parity of 0. No, wait. So I'm initially at position 0. That means I do have to do whatever that is. So this is going to be nums mod 2. Okay. F score of pose. I'm going to use I. And then parity. Okay. So return 0 if I. Oh god, there's so many options for this. No, there aren't so many options for this. Because, well, I have two ways I can go about this. I can either go from one thing to the next position, or I could go from one thing to the next even and to the next odd. I think to the next position is easier to write, even though I think it does create some more extra possibilities I wouldn't actually want to take. Like, it's all positive, so there's no reason to skip anything of the same parity. I either want to choose the first even or the first odd, but that's easy to write. And we'll see if it turns out to be too slow, then I take another 5-minute penalty. Why not? At this point, I'm just trying to solve everything because my penalties are terrible. Return 0 if I equals nums.length. Okay. So option 1 equals score of I plus 1, parity. Option 2, oh, I need a memo. Return, my memo can be an array actually. So memo is going to be array.new of length nums.length plus 1. I need the other dumb case. And then in here, it's going to be array.length. Screw this, I'm going to do this one as a set. Why not? That's like, it's going to be quick to access, I think. Although I can try that and get yet another 5-minute penalty, because why not? Okay. So, return memo of I parity if memo of I parity. Okay, right, because memo, and actually in that case, because I'm checking this first, I believe this could just be nums.length. Okay, so score 2 is going to be score of also I plus 1. This will be nums at I mod 2, because that could be a different parity, plus nums at I, and I'm going to break this up into a different line, even though it's really the same thought. So this is option 2 minus equals x if, this is where I wish I could highlight, unless the parity is the same. Unless parity equals nums I mod 2. Yeah, so unless the old parity is the new parity, I would subtract from that, and then I just got to do memo of I parity equals whichever one is higher. Memorize, save, return. Love how I can do all that in one line. Yeah, that is fair. Where am I doing nums mod 2 like an idiot? Okay, that's going to be nums 0 mod 2. And I don't need to do class variable because it's already. Should be 13 and 20. Looking good. Now let's see it fail because it's too slow. Let's go. Okay. My time is not actually terrible yet. Okay. If I can get this problem, I'll have a good score. If I don't get this problem, I'll have a not terrible score, something like 40 minutes. Anyway. Okay. Return the number of ways n can be expressed as the sum of x power of unique positive integers. Oh, God. Oh, no. Oh, that's actually not that bad. Of unique positive integers. Is this really bad or is this not bad? Okay. So this is basically the coin change problem where you have a number of coins and you want to see how, but I can't repeat. Okay. The x power of unique positive integers. Okay. X can only go up to 5. Freaking TypeScript. X can only go up to 5. N can only go up to 300. Thank goodness. Oh no, but even if like X is 1, that might actually be the worst case. So if I have something like 300, I could do that in, what would that be? So 217, so I could go up to, no, it'd be higher than that. Like I could use up to 20 numbers, more than a bit over 20, but less than 30. Say it's 22 or 23. That's an estimate. So I could use 23 numbers, but I could also do 22 numbers, 21, 20. Okay. Shoot. Because it could go up to 300. Okay. So, and again, my time doesn't matter for this one. I'm just trying to finish. I have a bit over an hour. First things first, I want to figure out all the possible numbers I can use. So, I'm going to be really semantic here. Usable numbers equals empty array. And then I'm going to say I equals 1, while I to the power of x less than or equal to n. Usable numbers. I plus equals 1. Okay. So if this is working now, and I'm just going to test this. So going up to 10, I should have 149. Going up to 4, 1, 2, 3, 4. Great, that works. Okay, so those are the only numbers I need to consider. Meanwhile, my total is n. The numbers are in order. So I just need to account. So this is dynamic programming again. I just need to account for the possibility of using the number or not using the number, which means I'm going to have a memo that's going to be an array of length. Can't go higher than n, right? N plus 1 because I don't want to deal with boundaries, and who cares? Okay, so let me explain my thinking both for your benefit and for mine. So basically, I want to do it like this. I'm going to go through the numbers. Like, say I have the numbers 1, 4, 9, right, for 10. So I go through 1. I can either take 1, in which case the new number I'm trying to total to equal is 9, or I cannot take 1, in which case it's 10. Either way, I can't use 1 again because I'm keeping it unique, so then I move on to 4 and 9. So I move on to 4 where my target total is 10 or my target total is 9. And then for those different totals, I would try including 4 or not including 4. 4 turns out not to work for either one. 9 will work with 9 but not 10, so there's going to be one possibility. That's great. That's exactly what I want. Yeah. With 4, I can take 1 or not take 1. If I do take 1, then I could take 2 or not. I could take 3 or not. But once I've taken enough things that my current number is higher than the value I have left, then I also know I just failed. So that's no good. Okay. Okay, so I want to find the possibilities. Okay, so array.new, and then in each array, I'm just going to have a hash, why not? Okay, so I'm going to do ways, nums equals usable numbers, because I want it to be accessible. I don't need x or n anymore, except insofar as I'm going to do ways starting at position 0 and with a target of n. So ways starting at I, going to n. So return 0 because there are no ways if return 1 if n equals 0. Right? Because I can't use any later numbers. These have to be positive. Yeah, and they have to be unique. Okay. Oh, shoot. Mod. I've lost points on this before. Equals 10 to the 9 plus 7. They like using that number specifically because it's prime. And big. So it's not something that you'd ever get. It wouldn't change. It doesn't matter where you do mod in the program, basically. You get the same result if you do it only at the end or if you do it throughout. Okay, usually. So return 1 if n is 0. Great. Return 0 if I equals, oh boy, nums.length. Length. Return 0 if nums I is greater than n, because then, okay, so I had to do line 19 before line 20, because otherwise I get a boundary condition where nums I doesn't exist. But here, I'm at the point where, for example, I've taken 1 and 4, and I'm trying to get 10, so my new total is 5. 9 is not usable. I can end it early here. I mean, here it's not early, but I could end it here. And if this were longer, then it would be earlier. Okay, return 0 if nums I greater than n. And finally, man, most of my logic is in the earlier turn. I love it. I n if memo I n. Okay, and this memo actually won't get that big because it's only going to 300. And the other things would be, well, they could be up to 300 in the one case. Okay. So option 1, I really like memos with options. Equals ways of I plus 1 n. Option 2 equals, I just think options is an easier way to think about it. I plus 1 n minus nums I. So that's where I do take it. And here they're not actually options. I'm going to add them. So that's a bad way to think about it. No, because I can still think about it that way. Okay, so that's 0, 1. I think that's fine. So I'm just going to do at memo of I. Oh, and I like doing memo as a class variable instead of passing it in. I just don't like passing things in. That's why I make nums and memo class variables. I know that's not super standard, but 1. Okay, so I'm trying to think if this somehow results in something. You know what, I'm going to try it first. My intuition says this maybe would result in a case where I'm counting something that, but I think those all count as 0, where I'm like, I go partway through something and then I count cases, but I think that does return 0. I think these return conditions, I'm just not very sure about this, and I can't really articulate what the possible issue is. Fingers crossed. Let's go. Okay, that's all 4, right? I think I got all 4. So, dun 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 dun. And what did I get? 15-minute penalty? Okay, not bad. That's like half the time, 45 minutes. Got all 4. Finish time should be 45 minutes, right? 45, 46 maybe? Of course, that means, oh my god, you finished in 9 minutes? What the heck? 51, I got 4 penalties. Fine, that's fine. This score is going to go down because, yeah, this wasn't a super difficult contest, to be honest. I thought, like, the last question I think is pretty straightforward with dynamic programming. But yeah, hope this was fun to watch and helpful. I will revise and post my solutions with explanations if you want to see the actual code. That's it. Thanks for watching.